All right, so 14.6 is going to be the binomial theorem. So this kind of explains the binomial theorem. You have this big, long equation here that is your friend, but we have a way to do this other than using the binomial theorem. So again, this is using factorials. Little exclamation point means factorial. So like 4 factorial means 4 times 3 times 2 times 1. And you could do this every single time to figure out what numbers you're going to use. But there is also this nice thing called Pascal's triangle, which is something you have to memorize, but really you don't have to memorize it. Because if you look, there is a pattern that happens here. So Pascal's triangle helps you to multiply things together that are really, really big. Like in the past, if we had x plus 3 quantity to the 15th, we wouldn't make you multiply that out. But now we're learning something, the binomial theorem, but using Pascal's triangle instead to figure out what that is. So what Pascal's triangle helps you do is to figure out the coefficients in front of each of the terms. So hopefully when we look at this right away, we can see, we know for sure what the first and the last term is going to be. It's going to be 1 if you look at the pattern. And then the 2's and the 3's and the 4's and the 6's. So if we look at that, where do those come from? Well, 2 comes from 1 plus 1. 3 comes from 1 plus 2. 3 comes from 1 plus 2. 4 comes from 1 plus 3. We get 6. We get 4. We add those together. So the next column is going to be 1, 5, 10, 10, 5, and 1. So really, you don't have to memorize the whole Pascal's triangle. Maybe like the up to row 3. Up to row 3 you do, and then you go from there. So the next row would be 1, 6, 15, 20, 15, 6, and 1. And you could do this forever and ever, okay? You could continue to do that forever and ever and ever. So when you're multiplying something, like let's multiply x plus 2 squared. Okay, well we all know that that is x squared plus 2x plus 4. Okay, we could use the binomial theorem to figure that out. Okay, but we don't need to. But if it's x plus 2 to the 4th, then we do have to figure that out. All right, so you still have to realize that this part right here is what goes with those coefficients. Pascal's triangle helps us with this, and this, and this, and this. It just helps you with the coefficient, but we still have to figure out what happens after that. So let's look at these examples. So we're going to expand each binomial. So this would be x plus y times x plus y times x plus y times x plus y, but we're not going to do all that. Since it's to the 4th, we look at the n plus 1. So 4 plus 1, we look at row number 5. So those numbers right there. So we're going to have a 1, a 4, a 6, a 4, and a 1. Okay? Let me space those out better. All right, so the first thing you do, and it might be easy for you to use different colors, is we take the first term and we raise it to the 4th. So this is going to be times x to the 4th. And then we go down 1, x to the 3rd, x squared, x to the 1st, and x to the 0. Then we take the next one and we start with 0. Y to the 0, y to the 1st, y squared, y to the 3rd, y to the 4th. And then these signs could be different depending on what happens in your parentheses there. And now you just do the math. So 1x to the 4th times y to the 0 gives us x to the 4th plus 4x to the 3rd times y to the 4th. So 4x to the 3rd, y to the 1st, just y, plus xx squared y squared plus 4xy cubed plus 1, anything to the 0 power is 1, so plus y to the 4th. And there is your binomial expanded. All right, 2x minus 3y to the 3rd. So we take the exponent plus 1, and that is the row we use. So now we're going to use 1, 3, 3, and 1. Again, you don't have to use different colors, just if it's helpful. So now here it's important to put that 2x in parentheses. So 2x to the 3rd, 2x, and go down 1, 2x to the 1st, 2x to the 0. Then we take the 3y, and 3y is negative, so we need to be sure to include that negative in our parentheses. So negative 3y to the 0, negative 3y to the 1, negative 3y to the 2, negative 3y to the 3rd. And then again, you can just put plus signs. Now these signs could change depending on what the term is right there, but we're not multiplying. And so now again, we just do the math. Now you might need a couple steps on this one. So 2x to the 3rd is going to be 8x to the 3rd. Anything to the 0 is 1. Here we have plus 3 times 2x squared is 4x squared times negative 3y. So I'll come back and do the rest of that here in a second. Here we have 3 times 2x times negative 3y times negative 3y is 9y squared plus 1 times anything to 0 is 1, so negative 3 to the 3rd, negative 27y to the 3rd. So now one more step right here. First one, 8x to the 3rd. Then we have a 3 times 4 times 3, so that's negative 36 x squared y. Then we have a 3 times 2 times 9, so plus 54 xy squared minus 27y cubed. So there is your completely expanded binomial. All right, to the 4th. So we look at row number 5. So row number 5, we have a 1, a 4, a 6, a 4, and a 1. And if you want to do all the first terms and then go to the second term, you can do that also. Again, the parentheses are important here. So 2x squared to the 4th. Important to put that in parentheses. 2x squared, go down 1. 2x squared squared, 2x squared to the 1st, 2x, let's move this over, we had a 1, and then a 2x squared to the 0. Then we do the 1. Okay, well 1 should be pretty easy on this one. 1 to the 0, 1 to the 1, 1 squared, 1 to the 3rd, 1 to the 4th. Again, then we put pluses between everything, but those signs could change. So 2x squared to the 4th would be 16 power to a power. We multiply. 2x squared, so we can't do 4 times 2, order of operations, PEMDAS. So that's 8 times 4, 32x to the 6th. 4 times 6 is 24, x to the power to a power. Again, 1 squared, we're multiplying by 1, so that doesn't do anything to our problem. Multiply something by 1 doesn't change it. Here 2 to the 1st is 2 times 4, so we get plus 8x squared. And then anything to the 0 power is 1. 1 times 1 times 1, so plus 1. x minus 1 to the 5th. I think you can do that one on your own. You need to come into tutorials. Your teacher will help you with that one. Now, this next one, it's not that bad. Okay, it looks like it could be that bad, but you just got to pay attention to all of your numbers as you're writing this. So 6 means we're looking at row 7. So we have a 1, a 6, 15. You got to use a lot of space for this one. A 20, a 15, a 6, and I'm going to have to go down to the side a little bit, and a 1. All right, so that 1, that first term is going to be easy because it's 1. Doesn't change anything, but we're still going to write it. So 1 to the 6th, 1 to the 5th, 4, 3, 2, 1, and 0. Then we have our root 2. So we're going to start out with root 2 to the 0, root 2 to the 1, squared, third, to the 4th, to the 5th. So remember, the first term you start with 6, the exponent, and go down to 0. The second term you start with 0 and go up to 6. And then we have plus, 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 and plus. All right, so it's not a calculator problem. We don't need a calculator for this. We just got to keep track of all of our roots. So 1 times 1 to the 6 times root 2 to the 0. 1 plus. Now we have 6 times 1 times root 2. 6 root 2. There's no minus signs involved, so we don't have to worry about negatives. So 15, the square root of 2 squared is just 2. So 15 times 1 times 2, 30. Plus. Now here we have 20 times root 2 to the 3rd. So root 2 to the 3rd is root 2 times root 2 times root 2. Root 2 times root 2 is 2 times root 2. So what we end up here with is 20 times 2 root 2. So we'll simplify that in a second. Then we have plus 15. Now if we add another root 2, hopefully you'll start to see the pattern here with these root 2. Root 2 times root 2 is 2. Root 2 times root 2 is 2. 2 times 2 is 4. So we have 15 times 4. Plus, then we have 6. We have 4. We're adding another root 2 times 4 root 2. And then we have 1 times 1 to the 0 times root 2 to the 6. So if we add another root 2, we end up with 8. So just a little more simplifying to do here. So 1 plus 6 root 2 plus 30 plus 40 root 2, 15 times 4, 60, 24 root 2 plus 8. So now we just add like terms. 1 plus 30 plus 60 plus 8, 99. 6 root 2, 40 root 2, 24 root 2, add those, plus 70 root 2. So is it a little bit of work? Absolutely. It is not difficult work. Okay, not difficult work at all. Difficult work is if we would expect you to multiply all those together. So use Pascal's triangle. Write that down. You have to know it. That's not something that you will be given. You will have to know it. But just off to the side on scratch paper or something, write it down, and then use it. You don't have to memorize it if you know the pattern.